Hello everyone. In this video, we are going to discuss about similar figures as well as congruent figures from the chapter 6 triangles class 10 max. See, we will be discussing about some rules to decide whether two figures are similar or not also. Okay. See, two figures are said to be congruent if they have the same shape and same size. Two figures are said to be congruent if they have same size and same shape. That is, for example, you just consider these two circles. These two circles are of radii 2 cm. This circle is of radius 2 cm and this circle is of radius 2 cm. Okay, I just named the circle as A. This is circle B. You see, these two circles have same shape and same size. Okay, because both of them are having the same radius or same size and same shape. So, these two circles are congruent. So, the circle A and B, they are congruent. Okay, now two figures having the same shape but not necessarily the same size are called similar figures. Two figures having the same shape but not necessarily same size are called similar figures. That is, you just consider these two circles A and C. The circle A is of radius 2 cm and this one is another circle C which is of radius 1 cm. See, these two are A and C are circles, so they have the same shape. But their sizes are different. They are not of the same size. So these two circles A and C, they are similar, not congruent. These two circles A and C, they are not congruent but they are similar because they have the same shape. Okay, so two figures are said to be congruent if they have the same size and same shape. Okay, and you see the figures having the same shape but not necessarily the same size, they are actually called as similar figures. So A and C are similar figures. Okay, but they are not congruent figures. A and B are congruent figures because they have the same shape and same size. See, the first two circles A and B, these two circles are congruent as well as they are similar. For two figures to be similar, they should have the same shape. For two figures to be congruent, they should have the same shape as well as same size. So for circles A and B, they have the same size, they have the same shape, so they are congruent as well as similar. So all congruent figures are similar, but similar figures need not to be congruent. All congruent figures are similar, but the similar figures need not to be congruent. Now, consider these three squares A, B and C of different sides. Okay, the side length is different for all the three squares. All of them are squares but their sizes are different. So, all these squares A, B and C, they are similar because all of them have the same shape. Okay, now if you consider the square and this triangle. See, these two are not similar figures. They are not similar figures because they do not have the same shape. Okay. See, there are some rules to decide whether two figures are similar or not. The rule is two polygons of the same number of sides are similar if their corresponding angles are equal and if their corresponding sides are in the same ratio. Both of these two conditions must be satisfied for two figures to be similar. So for two figures to be similar, there are some rules to decide it. That is, for two figures to be similar, these two conditions must be satisfied. Two polygons. Polygon means what? Poly means many, guns means angle. So polygon means it is a two-dimensional closed shape made of straight line segments that meet their endpoints. Okay, there will be many sides as well as many angles. Okay, now two polygons of the same number of sides are similar. So when we check the similarity, we have to consider two figures of same number of sides actually. So two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Let us just explain this rule by using these two quadrilaterals ABCD and PQRS. See, quadrilateral means it is a four-sided figure. It will have a quadrilateral will have a four sides, four corners, four angles like that. So here we have two quadrilaterals. One is ABCD, another one is PQRS. We have two quadrilaterals. Okay, see here we have two polygons, that is two quadrilaterals. They have equal number of sides. This has four sides. This also has four sides. So here you see the vertex A corresponds to the vertex P. The vertex B corresponds to the vertex Q. The vertex C corresponds to the vertex R and the vertex D corresponds to the vertex S. Symbolically, these correspondents are represented by using one such symbol. So you see the vertex A corresponds to the vertex P in the second quadrilateral. The vertex B of the first quadrilateral corresponds to the vertex Q of the second quadrilateral. The vertex C of the first quadrilateral corresponds to the vertex R of the second quadrilateral. Similarly, the vertex D of the first quadrilateral corresponds to the vertex S of the second quadrilateral. Now you see, corresponding to the vertex A of quadrilateral ABCD, we have an angle 105 degree. Vertex A corresponds to vertex P of the second quadrilateral. Corresponding to P, here we have the same angle 105 degree. Similarly, corresponding to the vertex B, we have 100 degree here. Corresponding to Q, we have 100 degree here. Corresponding to the vertex C, we have 70 degree here. The vertex C corresponds to the vertex R of the second quadrilateral. So here we have 70 degree, here also we have 70 degree. Similarly, corresponding to this vertex D of the first quadrilateral, we have 85 degree here. This vertex D corresponds to the vertex S of the second quadrilateral. So corresponding to this S, here we have 85 degree. Same angle. Okay, that is all the corresponding angles of these two quadrilaterals are equal. Okay, so the first condition is satisfied. The corresponding angles are equal for these two quadrilaterals. Now, let us take what about their corresponding, sides. So you see, corresponding to the side AB of the first quadrilateral, here we have the side PQ of the second quadrilateral. So the ratio of these two sides, that is AB divided by PQ, that will be equal to 1.5 centimeter divided by 3.0 centimeter. This is actually equal to 1 by 2. Centimeter cancelled. 1.5 by 3.0 into 10. So 15 by 30, which is 1 by 2. Okay, similarly, corresponding to this side DC. Okay, corresponding to this side DC, here we have this side RS or SR. So the ratio of these two sides, that is DC divided by SR, is equal to 2.4 centimeter divided by 4.8 centimeter. When you do this calculation, you will get it as 1 by 2. Okay, similarly, corresponding to this side AD of the first quadrilateral, here we have this side PS of the second quadrilateral. So the ratio of these two sides AD divided by PS is equal to 2.1 centimeter divided by 4.2 centimeter. When you do this calculation, you will get it as 1 by 2. Okay, similarly, corresponding to this side BC of the first quadrilateral, here we have this side QR. So when you take the ratio of these two corresponding sides, that is BC divided by QR, we will get it as 2.5 centimeter divided by 5 centimeter. When you solve this, you will get it as 1 by 2. Okay, that is, you see, all the corresponding sides are in the same ratio or same proportion. So the second rule or condition is also satisfied. So, here you see when we compare these two quadrilaterals ABCD and PQRS, their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. So, these two quadrilaterals ABCD and PQRS, they are similar. So, these two quadrilaterals are similar. Okay. Now let us see the remark. If one polygon is similar to another second polygon and this second polygon is similar to a third polygon, then the first polygon is similar to the third polygon. That means, suppose we have three circles here. Okay, or you can consider three squares maybe. Let us consider one is this square, another one is this one, another one is this one. Consider these three squares. I am naming it as A, B and C. If the first polygon, that is first square, is similar to the second polygon, that is if A and B are similar and if B and C are similar, then A and C will be also similar. Okay, if the first polygon is similar to the second polygon and second is similar to the third polygon, then first polygon will be similar to the third polygon. That is, if A and B are similar figures and B and C are similar figures, then A and C, they will be similar. Okay. Now, consider two quadrilaterals. One is a square ABCD and this one is actually, it looks like a square, but what I meant is actually this is a rectangle. Consider this as a rectangle PQRS. Because you see these two sides are marked as 3.5 centimeter and these two sides are 3 centimeters. No? So this is not a square. You have to consider it as a, it looks like a square, though it looks like a square, please consider it as a rectangle. So here we have the square ABCD, here we have the rectangle PQRS, two quadrilaterals we have here. Now you see, when you see the angles, all these angles are 90 degree, no? So corresponding to vertex A, we have 90 degree. Corresponding to the vertex A, here we have vertex P and the corresponding angle is 90. Corresponding to this vertex B, here we have 90 degree. Corresponding to vertex B, here we have vertex Q and the angle is 90 degree. So here all the corresponding angles are equal. So the first condition for two figures to be similar, it is satisfied. Now, what about the ratio of their corresponding sides? See, the side AB, okay, corresponding to the side AB, here we have the side PQ. So the ratio of the corresponding sides, that is AB divided by PQ, this will be equal to 3 centimeter divided by 3.5 centimeter. Okay, you can just multiply the numerator and denominator with 10. Centimeter cancels. So this becomes 30 divided by 35. When you solve this, you will get it as 6 by 7. Okay, similarly, corresponding to this side DC, here we have this side SR. So the ratio of these two corresponding sides, DC divided by SR, that will be equal to 3 centimeter divided by 3.5 centimeter. Again, you will get the same ratio, 6 by 7. Okay, now corresponding to this side AD, here we have this side PS. So the ratio of these two corresponding sides AD divided by PS, this is equal to 3 centimeter divided by 3 centimeter, which is equal to 1 by 1, or this is equal to 1. Okay, corresponding to this side BC, here we have this side QR. So ratio of these two sides, again 3 centimeter divided by 3 centimeter, which is equal to 1 by 1, that is 1. So you see, all the corresponding angles of these two quadrilaterals are the same. But the ratio of corresponding sides, they all are not the same. See, this is 6 by 7, this is 6 by 7, okay. But this is not 6 by 7, this is also not 6 by 7. So the ratio of all the corresponding sides are not the same. So these two figures are not similar figures. Okay. Now consider another two quadrilaterals, a square ABCD and a rhombus PQRS. Okay, see here the ratio of any two corresponding sides will be, you see here all these sides are having 2.1 centimeter length, here all these sides are having 4.2 centimeter length. So when you take the ratio of any two corresponding sides, you will get the ratio as 2 centimeter divided by 4.2 centimeter, which is actually 21 by 42 into 10 into 10. So this is actually equal to 1 by 2. So the ratio of any two corresponding sides of these two quadrilaterals will be 1 by 2. That is same. Okay, all the corresponding sides are in the same ratio. But what about their corresponding angles? You see, all these angles are 90. But these angles are actually not 90. So here the corresponding angles are not equal. So these two, the quadrilaterals, they are not similar. Okay. That is, these two quadrilaterals are actually two polygons. Okay, they have the same number of sides. Here we have 4 sides. Here also we have 4 sides. But you see, two polygons of the same number of sides are similar only if their corresponding angles are equal as well as their corresponding sides are in the same ratio. Here the corresponding sides are in the same ratio. One condition is satisfied, but the corresponding angles are not equal. So the another one condition is not satisfied. So here these two figures are not similar figures. I hope it is clear to you. Thank you.